Hello everyone, I'm Dylan and welcome to DevLab. Today, we'll take a look at some images from popular games. Can you notice a common element? That's right, it's the inventory feature, an essential component in most game genres. In this video, we'll explore how to build a simple yet powerful inventory system using Unity, something you can seamlessly integrate into your future game projects. Now, let's move on to the demo to see the results after developing the inventory feature in our game. All assets used in this video are free on the Unity Asset Store. My reference link is below the video description. Firstly, we have a demo character that can move around. When near an item, its basic information will appear, and by pressing the F key, I can pick up that item. I use the B key to open and close the inventory, where I organize items in a list of slots. Each item has an image and detailed information to make it easily recognizable for players. When near an item, its basic information will appear. Additionally, the sorting and filtering feature based on the quantity of items makes management more flexible. Finally, I can drop the item out by dragging and dropping out like this. And those are the main features we will build for this inventory system. Remember, this feature can be customized and expanded based on your specific game needs. Now, we will begin our journey in building an inventory system from scratch using Unity. I have an empty project here. I'm going to create a script called ItemData, and this is where I'll store all the data for items. ItemData will inherit from scriptable object. Inside, we'll have variables such as item ID, item name, description, max stack size, and icon. Below are public functions so other classes can get data from ItemData. Additionally, ItemData also implements the iSerialization callback receiver interface. Within this interface, there are two methods, on before serialize and on after deserialize. I use the on before serialize method to run a piece of code automatically generating an ID for the item when an item data is initialized. Now I can go back to the Unity editor to create a new item data and add the necessary data to it. In my inventory system, I'll be dividing it into slots. So I will create a class, InventorySlot. This class will be the place to store the item and its quantity. Now let's dive into the implementation of the InventorySlot class. This class is a normal C# class. Inside, I have two variables, item data and stack size. There are initialization functions to create a new slot. The clearSlot function is used to remove an item from this slot. Update InventorySlot function updates the slot's data. CanAddStackSize checks whether this slot can accommodate additional items. GetRemainingSpace retrieves the amount of items that can be added to this slot. AddToStack adds a specific quantity of items to this slot. RemoveFromStack removes a specific quantity of items from this slot. The SplitStack function is used to split the quantity of items in this slot into two parts. If the current quantity of items is less than or equal to 1, it's naturally impossible to split, and the function will return false. However, if it's greater than 1, I'll divide the current quantity and use math.roundToInt to round it to the nearest integer. Finally, I'll assign the value back to the SplitStack parameter and return true. Lastly, the isEmptySlot function is used to check whether this slot is currently empty or not. Now that we have item data and InventorySlot, let's move on to the inventory system class. This is where the main logic for this feature will be housed. Here, there is a list of slots and a variable to set the size of that list. Additionally, there are two events, onInventoryChange to notify whenever the inventory changes, and onInventoryFull to signal when adding an item, but there's no available slot to accommodate the item. We will move on to the first function, adjustSize, which is used to set the initial size of the inventory based on the previously declared size variable. The context menu attribute enables executing adjustSize method on right-clicking the component in the editor. This feature enhances convenience and expedites the development process. The findSlot function searches for a slot in the inventory that matches the provided item data and isn't already full. If a slot is found, it is returned. Otherwise, null is returned. The hasFreeSlot method finds the first empty slot and assigns it to the freeSlot parameter. FirstOrDefault is a link method used to return the first element in a collection or sequence that satisfies a specific condition. The candidatum method is used to check whether an item can be added to the inventory. Next up is the addItem method with two parameters, ItemData and amount. To start, we create a temporary variable to store the value of amount. This will help us keep track of the remaining quantity we want to add to the inventory. Next, we use a while loop to add each portion of amount to the inventory until amount decreases to 0. This ensures that we process the entire quantity of items we want to add. Within the loop, we first call the findSlot method to check if there's a slot in the inventory containing item data matching the item data parameter. If there is, we calculate amount_add, the number of items that can be added to that slot without exceeding the remaining space. We then call the add_stack method from the InventorySlot to add amount_add to that slot. Next, we decrease the amount value by amount_add and repeat this process until amount reduces to 0. If there's no slot containing the item to add, we check for an empty slot by calling the hasFreeSlot method. If there is one, we calculate amount_add similarly to before and call the updateInventorySlot method to update the information of the new slot with item data and amount_add. Subsequently, we decrease the value of amount by amount_add. If neither of the above cases is satisfied, it means the inventory is full and we cannot add any more items. We handle this situation by calling the handleInventoryFull method. Within this method, we create a log message indicating how many items have been successfully added to the inventory, invoke the event signaling that the inventory is full, and then call the event signaling that the inventory has changed. Finally, if we have successfully added the entire quantity of items to the inventory, we invoke the event signaling that the inventory has changed and return true to indicate that the process of adding items was successful. After getting the addItem method, we will try to add the item to the inventory. I will write a short code to test this feature. Returning to the editor, we must obtain references from the InventorySystem and the previously created item data. In this demo item data, I've set the max stack size to 2, meaning each slot can only hold 2 of these items. Now I'll run the game. When I press the G key as set up earlier, 2 items have been added to the inventory. If I change the max stack size to 3 and press the G key again, the item will continue to be added to the existing slots until that slot is full. Only then will it start adding to a new slot. Okay, so we've completed the first part of this series on the inventory feature. I hope this explanation has helped you understand more about how to implement and deploy a basic inventory feature. If you have any questions about this, please leave a comment below the video. I'll try to respond as soon as possible. Make sure to hit the like button and subscribe to my channel to keep up with new content. Thank you for your support.